Hi everyone, today we're talking about finding the area between two curves. And so if I'm given two functions, we'll say, it doesn't matter what they look like, we'll call this one f and we'll call this one g. Okay, and I want to take the area between them from a to b, meaning I want this area right here in between them. All right, well if I take the integral of g from a to b, it's going to give me all this area. Now if I take the integral from a to b of just f, it's going to give me all this area. Okay, and so what I want is just where I have these lines right here. Everywhere where I have these crosses is area that I want to get rid of. And the way we can do that is by subtracting. And so if I take the integral from a to b, what I can do is take the integral of f, which is the area of f, and subtract this area of g down here. Okay, and this actually ends up always being true. And the rule here is I'm going to take my top function and subtract my bottom function. And that will give me the area between them. It doesn't matter where the x-axis is. It doesn't matter if g is down here. Okay, you're just always going to do the top function minus the bottom function. Okay, now if our two functions are in terms of y, so for instance, if I have, I don't know, like some kind of parabola, which is pretty common, and then some kind of linear function, which is pretty common. All right, well, I first need to figure out where I'm intersecting. So I need to figure out where my points are, okay? And then I want to figure out what this area is. And so as a similar rule, if you kind of tilt your head, you can see that it's very similar to this situation up here where I kind of have a top and then a bottom, except we're going to talk about it a little different. We're going to do right minus left instead. Okay, and so if I take my integral, remember this is in terms of y, from a to b. Okay, you might also see this written as c to d because these are y values, but I'll just write a to b. It's going to be my right function, which I'll call g, that's my parabola here, minus my left function, which I'll call f, and that's my linear function right here. And remember, this is in terms of y. Okay, so if you have functions in terms of x, it'll always be top minus bottom. If you have functions in terms of y, it's always going to be right minus left. All right, so let's actually practice. Okay, so I'm given two functions. I want to find the area bounded between them. And so my first function, we'll just draw a picture here. My first function is 3 minus x squared. I know that's an upside down parabola that has a y-intercept of 3. And then my second function is linear with a y-intercept of 1. It's going down. Okay. So those are my two functions. I want to know what this area is. Okay, well first I need to figure out what these 2 points are, right? Because that's what's bounding my area. And so that's kind of like my a and b values. So my first step is going to be to find my intersection points. Right, first step always is going to be find intersection points because I need bounds for my integral. And so I'm just going to set these two functions equal to each other. Okay, and if we solve, or move everything to one side, I get a quadratic if I can factor this. So I end up getting that x is 2 and negative 1. All right, so I got my 2 points. Second step is going to be to take the integral of top minus bottom because these functions are in terms of x. So I'm going to take the integral from negative 1 to 2 of my top function, which is my parabola, 3 minus x squared, minus my bottom function, which is my linear function. right? And all this is with respect to x. Right, so this is the same thing as the integral -1 to 2. We already actually combined these right here. And so I'll just do this work. 2x minus x squared. Right, so just a little bit of algebraic simplification and actually evaluating the integral. I get 2x plus 1/2 x squared minus 1/3 x cubed from -1 to 2, which gives me an answer of 4.5. All right, so the area between these two curves is 4.5. All right, let's try another one. All right, this time these are in terms of y. And so one function is a parabola, one function is linear, just like in the example I did earlier. And so I know right here I have a parabola with an x-intercept of 5. Okay, and then right here I have a linear function with an x-intercept of 1. I'm just going to go up. All right. Sorry, x-intercept of -1, I should say. And I want to find the area bounded between them. So again, I need to figure out what my intersection points are. I need to know what this point is and what this point is. Those are my a and b values. So I'm going to set these two equal to each other. First step is going to be to always set these equal to each other. All right, so again, I have a quadratic. I can factor this. All right, so I get that y is -3 and +2. So those are my two bounds. Second step is going to be to integrate. So from -3 to 2, it's my area. And we're going to do right minus left. So my right function is my parabola. So 5 minus y squared. My left function is my linear. We're doing this with respect to y. Right, and if you evaluate the integral, you get 125/6, which is approximately 20.833. All right, now let's do one a little different. So again, I have two functions, and this one we can work out in our calculators. So my first function is to the 6th, so it's going to be real skinny. It's going to look like this. My second function is linear with a y-intercept of 2, and I want to figure out this business right here. All right, so I can take my integral, or I can set up my integral, I should say. First, I need to find my intersection points. So I'm going to set x to the 6th equal to x plus 2. That's my first step. So I get x to the 6th minus x minus 2 equals 0. And then right here, I probably need to use my calculator. Okay. So I'm going to go to my y equals 6 minus x minus 2 All right, so let's find these intersections. All right, so my first intersection is -1, so I'm going to write that down. And then we can do that again. My second intersection is 1.214. We truncate after 3 decimals. Okay, so I'm going to set up my integral now. I'm taking the integral from -1 to 1.214 of my top function, which this time is my linear. All right, so x plus 2 minus my bottom function, which is my parabola with respect to x. Okay, now again, we can do this one by hand, or we can plug it into our calculator. So let's just practice plugging into our calculator. All right, so we go to our alpha window menu, go to int, -1 is our bottom bound, 1.214 is our top bound. We have x plus 2 minus x to the 6th. With respect to x, hit enter, and I get an answer. Okay, so that's using our calculator. All right, last one. This is a little different. I have two functions here, and this time it looks like I have a cubic, and it actually intersects it 3 times. So I have an intersection point here, here, and here. So I'm going to call this intersection point A, the next one B, and this last one C. Okay, so in order to figure out what all of this area is, I'm actually going to need 2 integrals. Okay, because my top function and my bottom function switch halfway through. So my first integral is going to be from A to B. My top function looks like G. My bottom function looks like F. Okay, so my next integral goes from B to C. Now this time my top function is F, and my bottom function is G. So they just switched halfway through, and that's fine. So however many times your function intersects, you just need to set up some more integrals, but that's fine. All right, that's it for today. See you all later.